Okay, so in the last class we started plotting points. We found the distance, the midpoint, and the slope between 2 points. But we're moving towards an idea that there's an actual connection between the x and the y coordinate. So today we're going to talk about relations and functions. So a relation is a set of ordered pairs. And so we call the set capital A. We say it's equal to bracket, and we put a bunch of points. 1, 2, 3, 4, 5, 6, and 7, 8. Close brackets. We identify the x values. We call that the domain. So that's 1, 3, 5, 7. And we call the y values the range. In more advanced classes, it will be called the codomain. But in this class, we call the y values the range. And so we have 5 ways of representing a relation. So there's 5 ways of representing a relation. And you've done this before. The first way is a set of ordered pairs. The second way is you make a graph. The third way is you make a table. So for example, here's our table. Here's my x values. Here's my y values. 1, 3, 5, 7. 1 corresponds to 2. 3 corresponds to 4. 5 goes to 6. And 7 goes to 8. The fourth way is something that I love. It's called mapping. And I like this. It's like a visual. What you're going to do is draw 2 ovals. The first represents the domain. And the second oval represents the range. You're going to write the domain values in 1, 3, 5, 7. And when I say mapping, I mean how do we go from the domain to the range? And the idea is that 1 goes to 2, 3 goes to 4, 5 goes to 6, and 7 goes to 8. The last way we can represent a relation, number 5, is by a rule. The question is, once again, are these just random points, or are they connected some way? And some of you might say, oh, I would rather take the x value. To go from the x value, we have to add 1, right? So 1 goes to 2, 3 goes to 4, 5 goes to 6, and 7 goes to 8. So the rule is our y value is equal to x plus 1. This is a rule. Okay? Good. Next thing we want to talk about in this class is something called a function. And you're going to need to get this definition down. A function is a relation in which each and every element in the domain goes to 1 and only 1 element in the range. So every x value goes to only one element in the range. So let's look at some real life examples of why this is important to us. So let's let our domain in the first example be the days of the week. Monday, Tuesday, Wednesday, Thursday, Friday. Actually, I'm sorry. So let's make this Sunday through Thursday. And the range is going to be number of kids absent. Right? And I tell you that there's one kid absent on Sunday, 2 kids absent on Monday. There were 5 kids absent on Tuesday, 7 kids absent on Wednesday, and 0 kids absent on Thursday. Is this relation a function? Where is Sunday going? To 1. Anywhere else? No. Good. Where is Monday going? To 2. Anywhere else? No. Good. Where is Tuesday going? Where's Wednesday going? Where's Thursday going? They're all going to one place. That's fine. How about this next example? Same idea, days of the week and kids absent, but every single day there was no kids absent. So it would look something like this: Sunday, Monday, Tuesday, Wednesday, Thursday, and they all go to 0. So is this a function? Is this a function? And the answer is yes. How many kids were absent on Sunday? 0. Any other number? No. Monday, Tuesday, Wednesday, Thursday all go to one place and only one place. That's 0. So let's see. Function. Function. In the third example, let's say that we have data and it looks something like this. And we have So this is the chart that Miss Imelda came up with. This is the information she got back. And so, is this a function? And the answer is no, because she has 2 pieces of data for Sunday. How is it possible that Sunday there's 5 kids absent and 3 kids absent? And so you can visually see this. So it's like, no, not a function. Once again, Sunday cannot go to 2 places. That doesn't make any sense. Monday cannot go to 2 places. That doesn't make any sense. Another reason that it's not a function is because we didn't use this element in the domain. That's a little advanced. You don't have to worry about that. Nice. Okay. The next thing is, but we're not interested in days of the week. We're interested in numbers, right? So the question is, what's another way? Well, you can do the arrows, or you can do something called, so we're interested in numbers and also graphs. So you can use something called the vertical line test. The vertical line test. And this proves if a relation is a function. Right. So the first thing is look at the graph. So you're going to plot the points. You can use, Monday, Tuesday, Wednesday, Thursday as your x-axis, and the number of absences along your y-axis. You're going to look at the graph, and the thing is, if a vertical line anywhere crosses 2 or more points, then the relation is not a function. Let's use this as an example. In the first example, right? In the first example, right, I had Sunday, Monday, Tuesday, Wednesday, Thursday. For Sunday, I had 1. Monday, I had 2. Tuesday, I had 5. Wednesday, I had 7. And Thursday, I had 0. I'm going to draw vertical lines through all my points. Let's see, vertical line, only 1 point, good. Vertical line, through 1 point, good. Vertical line, good. 1 point, perfect. And this one works also. Let's see one that doesn't work. Let's look at so this is good. It's a function. Let's look at the last example to see how it doesn't work. So I'm going to do another graph, right? And I'm going to do, let's see, sorry, I should extend this out. Let's do Sunday, Monday, Tuesday, Wednesday, and Thursday. On Sunday, I have, let's see, I had 5 and 3. On Monday, I had 3 and 2. On Wednesday, I had 2, and Thursday, I had 2. And so you can draw your vertical line. Someone might say, oh, well, you know, it's fine because Thursday and Wednesday pass the vertical line test, but you say, no, Sunday fails it. Sunday fails it, and Monday fails it also. So it fails the VLT. VLT, vertical line test. Also, I can give you pictures. So, for example, on a graph, let's say we have a graph. Let's say we have a line. Does any line pass the vertical line test? Yeah. I can just draw vertical lines. It passes, it passes, it passes. So we're good. Parabolas, it passes. What about a circle? Is a circle a function? Is a circle a function? The answer is no, because it fails the vertical line test. So a circle is not a function. It's going to be important. Circles are important. They're just not a function. And we'll see over the years why this is a problem. Okay, let's move on. So the idea is we need a rule. So now we're into functions. And the idea is we have an x value and we're going to turn it into a y value. That's our goal. That's what we're going to be setting. Lines, parabolas, exponentials, like that's what we're doing for the next couple of years. So we need a rule to map x to y, and this is an equation that transforms x into y. So, for example, y equals 2x plus 1. And so we start with our domain, 0, 1, 2, 3, and you say, what does the rule do to my domain values? And you say, okay, it takes an x value, doubles it, and adds 1. So 0 goes to 1. Where does 1 go? Okay, double 1, add 1, 3. Where does 2 go? 2 gets mapped to 5. Where does 3 go? To 7. So this is the idea. You have to say, what's the rule, Mr. Adler? Now, you might see this. You might see this, but I'm going to change the notation. Instead of y, we're going to now use f of x. And instead of y equals 1/2 x plus 1, we're going to use this notation f of x equals 1/2 x plus 1. This is not f times x. It is not that. It's just the rule that transforms x into y. The second you see this notation, right, you just say, oh, we're changing x into y. So it's red. It's red, f of x. Okay? And one, yeah. Once again, it's just the rule. F of x is just the rule. So you're going to see if f of x is 3x minus 2, you're going to have to evaluate f of 7. All you're going to do is plug 7 into the rule. Substitute 7 into the rule. Right? So 3 times 7 minus 2 equals 21 minus 2, or 9. F of 7 equals 19. The idea is we have a domain value, we have a range value, and the rule of 3x minus 2 maps 7 to 19. What's f of 6? Well, you say, okay, the f rule takes 6 and multiplies it by 3 and subtracts 2, which equals 16. Once again, 6 gets mapped to 16. And you can plug this in any numbers here. That's the idea of f of x. And that's it. That's the idea. So that's the idea of functions. So once again, you're looking for, good. That's it. So once again, try these. How about, no, we're done. Good.